today we will be creating a Kubernetes observability stack using Grafana and Prometheus and with Istio inside the cluster. So this is the architecture of the Grafana and Prometheus, and first of all we will be setting up a local Kubernetes environment in kind and with load balancer Metallb. So I have already created my cluster. Let me show you Kubernetes get nodes output wide. So I am working with 3 node cluster with a control plane and 2 worker nodes. You can follow this GitHub repository and get the same cluster running. Okay, moving forward, first we have to install the Istio CTL. So I have already installed in my terminal. Going forward, we will be setting this profile for the Istio CTL. Clear, paste Istio install dash set profile demo minus y. So the Istio CTL profile has been set to demo and all the resources has been configured. Now let us move forward and we will be setting a label. The namespace Istio injection is equals to enabled. Let us go and paste it in the terminal. So the namespace default has been labeled. Going forward, we will be deploying the application, the sample application of book info. Copy, and we will be pasting in the terminal. It will install all the required resources for the application. So it's a microservices based application. Let us wait till all the resources are in the ready state. So let's check Kubernetes get all, and as we can see, all our resources for the application are in the ready state. Now let us move forward. Let us go to the product page and grab from the title, and we can have a title here, simple book store apps. So this means that the application is working. Now we will be opening the application to the outside traffic. For that we have to apply and install the book info gateway, the Istio ingress service. Okay, that's installed. Those resources are created. Now let us see that our configuration for the Istio CTL has no issues. So Istio CTL analyze, and okay, the validation issue found when analyzing namespace default. It's working fine. Okay, so determining the ingress IP and ports, set the ingress host and ports, copy these, go to the terminal, enter, set the gateway URL, echo gateway URL. Okay, so verify external access, echoing this URL. So this is the URL that we get. Let's open up, control click, and yes, our application is working. Now we will be applying add-ons for Kali, Grafana and Prometheus. For that, in this repository there is a directory for Istio samples add-on. We will do it recursively. Go to the terminal, paste it, and all the resources inside that repository will be created. And we can see here that it is saying Prometheus configured, deployment configured. So where the services is configured, I have changed those services from a cluster IP address to a load balancer. This is because I wanted to make use of Metallb that we have installed in our Kubernetes cluster. Okay, now we will copy this command, the rollout status for the KLE, and paste it in, and we will wait till all the resources are in the ready state. So as we are waiting for all the resources to be created, for the add-ons to be created, let me show you the Grafana and Prometheus YAML files. So this is the Prometheus YAML file, and it is creating the service account, the Prometheus template, config map, and in this config map we are allowing the data to accumulate. This will describe all the data from our Kubernetes and Istio, all the things. And in the Grafana, as we can see in the Grafana YAML file, so let me show you. Yes, in the Grafana config map again, we can see in the data and the data source YAML, we are data sourcing it from Prometheus 9090, which I will show you that this is the URL that Prometheus is working on, and from there Grafana will be taking the data. Okay, let us see if it has. Yes, all the resources I think has been created. Let us check. Kubernetes get all -n Istio system. So I think it is still in the creating state. Let us wait till all of them are in the running state. So let us clear the screen. Kubernetes get all namespace Istio system, and as we can see, all the pods are in the running state. All the services and all the deployments are in the running state. Okay, so let us move forward. Now actually let me show you the, let us go to the Prometheus dashboard. This is the external IP and this is the port that we will use, 9090. Okay, :9090. So this is the dashboard for our Prometheus, and for Grafana, let us go to this IP address with the port of 3000. Okay, so we are in the dashboard. Now first of all, let us go to the preferences, light, save, so we can see clearly what we are doing. Let's go to the dashboard, and as you can see, it has created for us the Istio control plane dashboard, Istio mesh, performance dashboard, service, workload, WASM extension, and let me show you the configuration. As you can see in the data sources, it has created Loki and the Prometheus. So let us go back to the dashboard, Istio, and let me show you the control plane dashboard. As you can see, at this moment we are not having any traffic, so let us create some traffic. This is the Grafana dashboard, the workload dashboard, and as you can see there is nothing to see yet, but what we will do is now we'll come to the K6 open source load testing tool. Let us go to the terminal. Let us go to a new terminal and Vim, and actually I have created this a script for the K6. For 1 minute it will have 200 virtual users, for 3 minutes 300 virtual users, and for 1 minute 100 virtual users. You can obviously change as you wish. Let me go back and K6 run temp average load.js. Okay, so now it is creating virtual users. Now let us go to our dashboard and we can see the users are gonna be visualized here. Let us refresh. Yes, now it is coming back. The incoming request is going up. Incoming success rate is 100%. The duration of the request, and as you can see, before it was at 0 operations per second, now it is increasing. So incoming request duration by source, incoming request size by source, response size by source. Okay, let us go to the control plane. So the pilot version, resource usage, memory, CPU, disk, coroutines, pilot pushes, pilot errors, proxy time, conflicts, ADS monitoring, envoy details. So much we can see from here. Let's go to performance dashboard. Okay, so we have vCPU usage. As you can see, before it has no our graph was stagnant, then it started increasing. Memory usage, byte transferred per second, memory vCPU. Okay, lastly let's go to this Istio service dashboard. Let's open all of them. First it's a general, so client request volume, 11.3 OPS per second, operations per second, and client success rate, client request duration, server request volume. Okay, cool. I think that's about it. So all the source code is available in the GitHub repo. Okay, thank you very much.